Hello, my name is João Pedro. I am the team leader of the ByteVolta team. I am responsible for 3D modeling and victim identification.
I'm Vinicius Ferreira. I'm responsible for general software and the exploration logic of the robot.
I'm Sarah, and I am responsible for the assembly of the mechanical and electronic parts of the robot.
My name is João Vitor, and I'm responsible for the design of our PCB.
And
we are the ByteVolta team!
The ByteVolta team started in 2022 after the pandemic and later evolved into its current form through selection tests.
Our first steps in building a robot began with a deep dive into the Rust maze lake. We studied every detail we could, analyzed the rules, exploring to the piece, checking buttons, and watching videos of past teams. We also spoke with former members from our school, who shared valuable insights, and that's how our journey began.
we have been heavily inspired to build a robot by our passion for technology and problem solving. We have always been curious about how robots work and how they can be used to help people. RoboCup feels like the perfect place for that. Our teachers have also really inspired us. They introduced us to robotics, and their support helped to spark our interest and gave us the confidence to build something meaningful as a team.
The robot was designed using Fusion 360 with a compact structure and a suspension system using springs for stability of the robot, and decentralized camera positions for wide victim identification.
The Open MV87 Plus is one of the best models on the market. It's ideal for identifying all the victims on the maze, which uses many sensors, just like distance sensors, RGB sensors, gyroscope and accelerometer, and infrared and encoder sensors, all of them integrated in your physical structure and PCB all designed by the team.
Key innovations include suspension for stability and accurate deployment kit system, and all custom PCB for reduced wiring issues, and a CNN to high accuracy detection.
Part of our programming class diagram is a single maze controller that defines our maze logic. Initializing the grid, exploring with DFS, and backtracking with BFS. It delegates sensing to LiDAR array, control to PID, orientation to MPU 60-50 fast angles, and uses a generic deck for its coordinate cues, keeping each concern neatly encapsulated. During DFS exploration, at each cell, the robot reads its LiDAR sensors to build a bit mask of open, unvisited directions, picks the next neighbor, turns toward it using a PID loop, and optionally aligns itself with the wall, then steps one tile and recurses. When no unvisited exits remain, it switches to BFS, finds the closest cell that still has unexplored neighbors, and backtracks there by following stored parent pointers, reorienting and realigning at each move. The biggest challenge we faced was orchestrating reliable BFS backtracking. I needed to accurately map walls during DFS, manage visited flags without corrupting the grid, and then have the robot physically replay that backtrack path.
ByteVolta team won the Latin American robotics competition in 2024. However, the same robot that won last year needs some change to compete in the RoboCup 2025. For example, in the movement of the robot, there are some issues to climb the ramps. To address this, the team will develop a suspension system for the motors. In addition of this, in the electric structure, we will design a printed board circuit to solve every electrical problems and change some components.
Our goal at RoboCup is to improve our robot, learn from other teams, and grow as a team. We also want to experience the job market by facing real challenges. More than competing, we aim to innovate and share knowledge and proudly represent our school and Brazil.